Students, in this video I am going to go over some factoring techniques. First I'm going to recap some of the factoring techniques that we are already aware of. So in the past I've emphasized in past videos that if you have a trinomial and you recognize this to be a quadratic equation that is a perfect square, you can then turn this into a minus b quantity squared. Having this ability to recognize quadratic equations that are perfect squares proves to be very useful, especially when it comes to like finding zeros of polynomials that have quadratic forms. And very often you'll see different applications in science where you will need to be aware of these quadratic equations. So another form that proves to be very, very useful that comes up all the time is the alternative, right? This a plus b quantity squared. Again, these are perfect squares. We also recognize that a squared minus b squared may be factored into a plus b times a minus b. What I'm going to do in this video is I'm going to add on to this list, and I'm going to attempt to figure out whether or not this factors into anything. So one thing that we have up our sleeves right now is the idea of the remainder theorem. So immediately upon inspection here, I already know, okay, that this a minus b will be a factor of a cubed minus b cubed. If you're wondering why that's the case, well, suppose I call y is equal to a cubed minus b cubed, right? According to the remainder theorem, all I got to do is substitute wherever a is. I want to replace that with b, and I'll get b cubed minus b cubed, and that is indeed 0. So this is consistent with the remainder theorem, right? So a minus b will be a factor. So what will it factor to? Well, a way for us to figure this out is we're going to perform long division here. So I have a minus b. It's going to be divided into a cubed minus b cubed, but I am going to write this thing out. So it's going to be a squared b, 0 times a squared b, plus a 0 times a b squared, plus b cubed. I'm sorry, minus b cubed. Okay, so these are going to be the placeholders in between. Okay, so let's see here. What can I do to figure out what this is? Let's see, a minus b, right? What do I need to multiply to eliminate the a cubed here? I need to multiply by a squared. So I'm going to multiply a squared with a minus b, and I'll end up with a cubed minus a squared b. I want to do a subtraction, and I'll end up with a squared b. I want to pull this thing down, plus 0ab squared. What do I have to multiply a minus b by to get a squared b? I will need to multiply by ab. So if I do that, I'll end up with a squared b plus, or actually minus, ab squared. And again, I perform a subtraction, and what I end up with then is ab squared. And I'm going to pull down the b cubed minus b cubed. What will I multiply a minus b by to get this? I'm going to multiply by b squared. So if I multiply by b squared, I want to multiply by positive b squared. So I get ab squared minus b cubed. And as was predicted, right, the remainder would be 0 because we understood that a minus b would definitely be a factor of a cubed minus b cubed. So hence, the difference of cubes will turn into a minus b times a squared plus ab plus b squared. Let's do this one more time for a sum of cubes, and let's see whether or not, again, it too will be factorable by something, right? So I have a cubed plus b cubed, and immediately I see here that if I have a plus b, okay, I immediately know that this a plus b will be a factor of a cubed plus b cubed. And why is that? Well, that's because if I, again, replace a with negative b cubed, so in other words, if I replace a with negative b, I'll end up with negative b cubed plus b cubed. Is negative b cubed plus b cubed, is that going to equal to 0? That indeed will equal to 0. I will, in fact, have a remainder of 0. So a plus b is, in fact, a common factor. So what will that factor to, though? So let's try to figure out what this is by using long division. So I have a plus b. I want to divide this thing into a cubed plus b cubed. And again, I'm going to do this in a very similar manner. So I have a cubed, and then plus 0 a squared b, and then plus 0 a b squared, and lastly plus b cubed. So what will this then factor or divide into, or how will this divide out? So I'm going to multiply a plus b by a squared, and what I'll get is a cubed plus a squared b, and I am going to subtract, and if I do, I'll end up with negative a squared b. I will do this again with minus ab, and if I do, oh, and I forgot to pull this down, so it's plus 0 ab squared. If I do, I multiply a plus b by ab, and I'll get negative a squared b minus ab squared. If I do the subtraction, I'll end up with, again, ab squared, and I pull down the b cubed. I'm going to multiply a plus b by plus b squared to get ab squared plus b cubed. And if I subtract, again, I will end up with 0. So what will a cubed plus b cubed, what will that factor into? That will factor into a plus b times a squared minus ab plus b squared. This is the factored form of a difference of cubes. And much like the structured way of factoring that was shown in past lessons, okay, the difference of cubes, again, needs to be internalized. And we're going to go through some exercises on factoring difference of cubes in another video. Here it is one more time.